Hello. So here I am sitting in my chair thinking about hybridization. And I thought maybe, just maybe, I thought I should share my thoughts with you. So let's talk about carbon. Carbon has a configuration here of 1s2, 2s2, 2p2. And if you're thinking of that, that should imply that when I look at methane here, CH4, that two of these bonds here might be different than the other two. I've got 2s2, 2p2, that these bonds should be different. But you know what? Here's the bizarre thing, is that all of the bonds are equivalent, meaning they're all the same length and they all contain the same amount of energy. How can that be? Well, you have this diagram, and what we're looking at here, this is carbon in its excited state electron configuration. We have the 2 electrons in the 1s, and you have the 2s, and that empty 2p orbital actually takes an electron, which again, this would imply that one of those bonds should be different. But carbon, its bonding orbitals undergo something called hybridization. And you think of the word hybrid. Hybrid means it's a cross between two different things. And what we have here is you've got the p orbitals and you have the s orbitals, and they merge to form what we call hybrid orbitals. And if you're thinking about energy, it's a higher energy than the 2s, but a slightly lower energy than the 2p. And so you get these 4 bonding orbitals that all have the same amount of energy. So what we're doing is we're taking part of the s and part of the p, and what we get here is what we call 2sp3, or sp3, which means it's 1 part s and 3 parts p. And that comes from the 3 p orbitals and the 1 s orbital. And so this is what we would consider to be hybridized. That these are bonding orbitals are all the same. And so this is what we kind of look at now as the shape of the bonding orbital. It's part s, part p, and it looks a little bit not like a p orbital up here, but it's a hybrid again. And when you get a head-on overlap, what you form are what you form are sigma bonds. And when you get a sideways overlap between orbitals, you get what we call a pi bond. Now, anytime carbon forms a single bond, they are always considered to be sigma bonds. And when carbon forms either a double bond or a triple bond, a double bond would be one set of p orbitals overlapping. A triple bond would involve 2 sets of p orbitals overlapping. You'd have 1 sigma bond and then 2 pi bonds. And this is a graphic that somewhat illustrates that. Here you've got a molecule of ethene. This would be a double bond between the 2 carbon, the 2 carbon atoms here. You've got hydrogen, 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 hydrogen. These bonds that you're looking at here are sigma bonds. And then the bond between the carbons here is a sigma bond. And then what you have here, you've got p orbitals that are sideways overlapping, and that's your pi bond. So this particular carbon, we would say it's not an sp3, but I'm taking the s orbital and 2 p orbitals to form my bonding orbital, so it'd be sp2, and then you have a pi bond with that. So here are three different molecules. And what I'm looking at for this carbon, I have 4 sigma bonds. They're all identical. They've taken the s and the 3p orbitals, and this is what we would call sp3 hybridized. So come on, there you go. That's sp3 hybridized. When I look at this carbon right here, I'm looking at, here's a sigma bond, and one of these is a sigma bond. So that would be sp2. The other bond that you have here between the oxygen and the carbon would be the pi bond. So this is sp2 hybridized, and over here I've got an sp, and then you have 2 pi bonds here. This would be, come on, this would be your sp hybridized. So this has an sp carbon, this carbon would be an sp2 carbon, and this carbon right here would be an sp3 carbon. So here's a molecule of, I believe this is vanillin. And my question to you is, how many sp2 carbons are there and how many sp3 carbons are there? You can pause the video right now if you want and work through this, and then in about 5 seconds I'm going to give you the answer. Alright, so let's do sp3. I've got 1, 2, 3, 4, 5, 6. I have 6 carbons here that would be sp3 hybridized. And again, you're not seeing the hydrogens on this, but that's what you got. And then the question, how many sp2 carbons? Here's 1, 2, 3, 4, 5, 6, and 7. So I see 7 sp2 carbons. And we can talk about this if you want a little bit on Tuesday, but that's what I see. Thank you. Good night.